Good afternoon or good evening, I should say, and welcome to tracing across your distributed process boundaries using OpenTelemetry. This is a kind of a replay of my talk I did at Epidays Live, Australia. This is a bit longer, so I get to share some more technical aspects and maybe spend some more time on the demo, which is always good. I see there's some technical folks here, which would probably suit as well. The theme for Epidays this year was accelerating digital, and the reason why I decided to submit this talk was we are kind of in this second wave of cloud adoption. And what that means to me is that it's no longer just enough to have a presence on the cloud. We need to thrive in that environment, and we're building these cloud native software distributed systems. And the thing that separates good teams from the not so good, in my opinion, is this observability aspect. And when it comes to observability, if anyone's been paying attention, OpenTelemetry is the next big thing. And in this talk, we'll cover some modern challenges when it comes to distributed tracing, or rather building distributed systems, and some modern solutions in way of OpenTelemetry. So for folks who don't know me, my name is Dasith Wijes. I joke that my name warrants putting Invacha Max in your SQL databases. But I'm a consultant. I've been working in Melbourne for a long time now, and I've recently joined Microsoft as an application development consultant. And there's a big push internally from Microsoft and from our product teams as well to adopt OpenTelemetry. And you'll hear a lot about this aligning with Azure Monitor as well. So I've been helping teams build distributed systems, and I've been talking about and blogging about this for a while. And one thing I've noticed is that a lot of the younger teams or younger developers or teams that don't have a lot of experience, and they start building distributed systems, they run into problems in production, and they don't have a good way of resolving them because they don't have good observability. So in this rather short presentation, I'll try to introduce you to the concepts of distributed tracing and then see how OpenTelemetry fits in. Like I said, I understand that most of you folks might already understand what distributed tracing is, but for completeness sake, let's set the context and the stage properly, and then towards the end, see how we can use OpenTelemetry and the concepts of OpenTelemetry to solve this. And if the demo gods are happy, I'll do a demo at the end. So talking about setting the stage, this is something that we've always been told that if you really want to control something, you have to measure it. And this is true in software development as well. And for software development, there are some specific problems I want you to think about. These are some thought experiments I've been doing when I think about observability. For example, let's say you've completed your sprints, you've deployed something, and your product manager comes to you and say, that thing you deployed, that's it, it's running slow. It's not performing as expected. Do you know what benchmarks you have? Do you know your CPU, memory, what the normal is? How do you determine something slow? Because it's a subjective term. And how do you know that feature you built is being used? Are you able to easily pinpoint to issues when something goes wrong? So it turns out that this ties in nicely to architecture as well, because if you're using your imagination rather than factual data coming out of your system to architect, you might be wasting a lot of your effort and wasting a lot of your customers' money as well. So how can you prove that the system doesn't scale for the reasons you think it doesn't? This is where we need those facts and observability aspects to drive the discussions, because as you know, architecture is all about trade-offs. So let's let's see how we can use this theme as a driving factor to discuss observability and distributed tracing. Let's look at a definition, because it's always good to look at a definition in a talk. This one's from OpenTelemetry itself. The thing I want you to focus is that we're building more and more microservices-like architectures. Let's say rewind the clock back 10 years ago and look at now, and I think vast majority of things that we're building now are somewhat distributed. So that's why this focus of tracing has come to the forefront. And on a good day, it's very hard to pinpoint a problem in a distributed system. On a bad day, nearly impossible. So to really understand what I'm talking about when it comes to distributed tracing, let's look at an example. So I've got this simple, crude example of a distributed system, only a few pieces, but this is enough. This is enough to do an example out of. We've got a request coming through some sort of front end. We've got this correlation ID, hopefully. Most systems don't even have that. The API gateway then forwards that to a middleware, which does some processing, saves some state to some sort of database, so persistence. Then there's some asynchronous processing through a queuing mechanism. The backend does the processing and saves the state to the same database, so some sort of persistence. Now, what would you do if you needed to focus on this single request in your current system? Think about this. Does it involve something like this, where you go to your log aggregation system, you try to put your correlation ID here? Hopefully you have a correlation ID. Unfortunately, most systems I work with, I try to put some weird character combination in the request and try to look for the logs there, because not many people implement structured logging properly, or worst case, they don't even have the contextual information logged. So and take sampling into effect, like Randy talked about, it can be a nightmare. So it turns out logs aren't the best tool for this. You don't want to be doing this when the production systems are on fire. You don't want to be looking at logs and trying to stitch everything together, trying to see where the request failed or how long a particular component took. Logs are okay. Don't get me wrong. I'm not depreciating or dissing logs. It certainly has its place, but not for distributed tracing, in my opinion. There are better tools for this. So let's have a look at what I mean by this. So this is another view of the distributed components of a system. This looks more like a real-world system where there's many moving pieces, and a request can traverse multiple paths through this. So what you want to be able to do as a software developer or as an ops person is, when something goes wrong, but for a particular request, see the path that request took in terms of your components. This is the kind of clarity you want. The focus, you need to be able to cut out everything, all the white noise from all the other requests, all the components that you don't need to know anything about, just this particular request. And this is what distributed tracing, and in particular OpenTelemetry, promises. And with using the right sort of tool for the backend monitoring aspect, and linking or forwarding the telemetry data to that, you can get a view like this. This is a temporal view of the same. As you can see, everything's nicely linked up. You can see what component took how long, how it's linked to the parents, the dependencies, and contextual information in one place. Similarly, because this particular backend tracks all of your requests, it can even come up with a component diagram for you. All of this coming from the rich information that OpenTelemetry provides. In this example, I'm showing you Zipkin, which is just but one of the monitoring tool that OpenTelemetry can support. Another popular one is Jaeger. I'm sure you've heard of it, if not used it. So if it wasn't clear, this is exactly the kind of tooling we want when something's going wrong in production and you want to debug and trying to understand the performance issues or availability issues. So I did mention that 10 years ago, distributed tracing was in as a buzzword, it is today. So what's changed? Why are we talking about this? What's this aura around OpenTelemetry suddenly? It turns out we're building more things that run on the cloud. This is quite obvious. And what isn't quite so obvious is that many software teams are building in 2 or more frameworks. Even teams that are internally, I would say, within my organization, it's not just .NET. There's a plethora of technologies, and this polyglot, I guess, environment means that we can no longer rely on a single framework to solve our observability or have a single worldview of the telemetry that it outputs. We need to have a single worldview that spans languages and frameworks. And it needs to also support many clouds, not just Azure, not AWS, Google Cloud. It needs to support it needs to be vendor agnostic and cloud agnostic as well. So considering all of that, the last bit I want to focus is the open source technologies we're building things on top of. For example, if I'm building a .NET application, the chances are there's a plethora of NuGet packages I'm using. I'm not going to reinvent the wheel. But when things go wrong, we can't simply treat those external libraries as black boxes. We need for them to participate in the same shared view of telemetry. And this is kind of the environment in which OpenTelemetry was born. If you look at these 2 projects, Open Sensors and Open Tracing, they tried to solve similar things in this space. They came together and formed OpenTelemetry. And traditionally, telemetry data has been provided by either open source projects or commercial vendors. Think about what you've been building maybe 5 years ago. We were heavily reliant on the cloud provider to give us the telemetry solution. If it was Azure, we had App Insights or Azure Monitor. If it was AWS, X-Ray, or whatever the equivalent is. But the key problem here is the lack of standardization. And OpenTelemetry was formed to solve this problem. And it solves this by providing a single vendor-agnostic solution. And OpenTelemetry currently has broad industry support, so all the major cloud vendors and telemetry backend providers, they all come together. And this is great news for us as software developers, because we can, without a question, start using OpenTelemetry now. It's currently in beta across multiple languages, but expect general availability pretty soon. So jumping straight into what OpenTelemetry provides for you, I personally, without going into too much detail, I personally like to think of this in my mind when I relate this to any sort of architecture. I tend to think of OpenTelemetry as a set of, I guess, standards, more so than anything else. It's a set of standards that you can use, and then you can complement that with a backend monitoring tool to visualize the telemetries provided by the OpenTelemetry standard. And the other thing here, like I touched on briefly, you can use OpenTelemetry to create and collect telemetry data in a vendor agnostic way, but then also forward them to a variety of analysis tools. So Zipkin, Azure Monitor, Jaeger, Prometheus. Even though they have their own, I guess, protocols, OpenTelemetry has a way of collecting in a telemetry data in a vendor agnostic way and then forwarding it to specialized backends. And it's a proud member of the Cloud Native Computing Foundation. What that means for you as a developer is it's got good buy-in from the community and the ecosystem, so you don't have to worry about whether this is going to disappear in a few years. And it, luckily for you as a software developer, again, integrates with most of the languages and frameworks, and there's instrumentation available from popular libraries in those frameworks as well. Right, so this is the time where we go into a bit more technical details when it comes to architecture. It's important that we understand, have a good grounding of this, because when you read the documentation, you'll see some of these words come through, and it's good to at least have a peripheral view of what these are. So OpenTelemetry is built on top of these two pillars, I would say. One is signals and one is context propagation. And the signals break up into three parts again: tracing, metrics, and baggage. And these are the telemetry types we want to capture. And context propagation is the mechanism that allows these particular signals to propagate from one process to the other, or even within the process, and have a relationship between one another. It's this context propagation that's a key selling point of OpenTelemetry. It's an open context propagation standard that OpenTelemetry advocates for. So, as you know, if you've developed any sort of software, you know that you have the built-in framework aspects, like in .NET or ASP.NET Core, you have the framework itself providing telemetry information. Like when take ASP.NET Core, for example, when a HTTP request gets handled, it creates its own telemetry data. Then you have your application code, that the things that you're writing. You might want to log something, or you might want to trace, create some traces or something that you're writing. Plus, you have those HTTP clients or database clients, or NuGet libraries that you import in. So all of these things are creating tracing information. And therefore, tracing is a cross-cutting aspect. It's something that traverses all of these layers. But there's a slight problem here from a capturing tracing point of view, because all of these layers have different concerns. And the way that OpenTelemetry kind of tries to solve this is by putting it into two categories called cross-cutting and self-contained. So cross-cutting, you can think of them as conventions and APIs. So API simply means cross-cutting public interfaces, like things that you can use for any language or any framework. Then you've got conventions, which are like, let's say, how a trace ID is represented in a HTTP header. Those are things that can be that are neutral to the language you're writing. Then you have these self-contained items, for example, the SDK. This is something you import into the language that you're writing, and it provides the kind of interfaces and APIs that you can use to create the telemetry data in an OpenTelemetry compatible way. The contrib here simply refers to the packages or things that the project is maintaining on behalf of I guess, the major languages and frameworks. For example, the HTTP client for .NET. I don't want you to get stuck on these details much, but just have maybe have a peripheral view of this. If this comes up in a conversation, just know where to go to look for more information around this in documentation. So for completeness sake, I want to talk about these these four components as well. I'll focus on the last two, which is the instrumentation libraries and collector, but simply know that Proto refers to language independent interfaces. That's one component. We touched on the specification. This is nothing to do with any language. It's a set of documents that live in the GitHub repo for OpenTelemetry, and it specifies how things need to function, and these are across all of the languages and frameworks. And it defines what the headers are, defines what names to use, things like that. Instrumentation libraries are things that enable instrumentation for your existing components. So take HTTP client in .NET, right? You want to make sure that the traces are captured from that HTTP client. You want to import an instrumentation library that enables that. You first install the instrumentation library for HTTP client and opt in. Same for ASP.NET Core. The instrumentation gets enabled by these libraries. It's different for certain other languages. For example, in Java, most of the things are by default instrumented, but in .NET at least, we need to use instrumentation libraries for majority of the cases. Now, this brings us to the big part of the biggest part of the components, which is the collector. I want you to pay attention to this because this really ties into how you will use OpenTelemetry from a architecture point of view. This view simply shows some, I would say, applications, and they are using SDKs directly baked in. So this is a NuGet package we've installed on the .NET application. And this is going to be the example I'm going to show you today in my demo. And we also import a exporter. I know importing exporter sounds very weird, but exporter is a NuGet library again. We put that into our application, and we can directly send telemetry data to a backend of our choice. So the SDK collects and captures the telemetry data. Then the exporter exports it to a backend of our choice. It can be Zipkin or Jaeger. The exporter will take care of talking to the backend in a protocol that it understands. Now, this is the way most of the .NET applications will be written. But there's another way of this being done. And the reason why is many, if you think of a typical scenario, like smaller companies, the operations team and the software development team work very closely. When you go to enterprise, though, the DevOps mindset might not always exist. You might have a development team and an ops team. And if you do this, and the ops team want to now suddenly change the monitoring backend tool, they'll have to redeploy each of the applications. And we want to avoid that. And the enterprise might use something like this, where we have this thing called an agent running as a sidecar or as another process alongside your application, and your application sends telemetry data in a standard way to the agent. And this agent is deployed by your ops team and controlled by your ops team, and it can then export to the backend of your choice. And likewise, you can also have a standalone OpenTelemetry collector running in let's say, a container, and all of these applications export to this particular collector, and from there forward into the backend of your choice. So this is another way of deploying the same thing in I guess, more suitable for enterprise where the ops teams in control of the monitoring backends. But regardless of your choice, it's the same thing happening where we are collecting things in a generic way, then exporting in a specific way. So this is the open architecture, or the internal components rather, of the collector in OpenTelemetry. So the reason why it can receive in many formats is because the OpenTelemetry collector is able to run in brownfield environments as well. Let's say you've written applications that are producing telemetry in a Jaeger format or in a Prometheus format. You don't want to immediately replace all of the Prometheus agents or Jaeger agents running. You simply use the OTel collector. It supports consuming those protocols. Then you can process them. You can do many things to that data. Then finally export it to, again, a open standard, Jaeger or Prometheus. So this can function in a brownfield environment as well. And that's what I'm going to show you next. I want you to focus on this left side first. Here, what we're doing is in a greenfield project where we are developing a new application, we simply can direct our, I guess, our telemetry data to the monitoring backend of our choice using the agent. I showed you in that enterprise example where we have an agent and we push it directly into a monitoring backend. But for brownfield environments, the collector supports many popular open source wire formats, including Jaeger, Prometheus, FluentBit, like etc. So for brownfield environments, if you don't want to change all your applications all at once, you simply can have an OTel collector consuming whatever proprietary formats of data supported, then pushing it to OTel collector, which puts it to the backend of your choice. This is a more extensible approach if you are in a brownfield environment. A good example of this greenfield approach is Dapper in my example. If you've ever worked with Dapper, you'll know that the Dapper sidecar pushes all of the OpenTelemetry data in by default. I think it comes with Zipkin, but you can choose any sort of backend monitoring tool. They do it through a OpenTelemetry collector. The Dapper sidecar pushes the telemetry into this collector, which processes it and then pushes it to whatever backend monitoring tool of your choice. And it gives you this nice visualization. And this is where I'm going to tie everything into a more technical example. And for that, we want to talk about the span. And it's just a matter of time if you're developing something that supports OpenTelemetry until this word span comes along. And for especially .NET, this word span is new for us. But if you've been using the activity API, they say the same thing in .NET is represented by an activity. In fact, the .NET team, rather than introduce this new thing called a span, reuse the existing activity class to represent a span. So for those who remember how I said there's 3 types of signals, tracing, metrics, and baggage. In OpenTelemetry, tracing is represented and defined by a span. A span can have a root and then children being spun up as it goes deeper like this. And you'll see that in the monitoring tools and also in examples. There's 2 ways you can visualize this hierarchy. There's the causal relationship, which is what was in the previous slide, where you've got the parent span, then the children. And take notice of how the child span have the same trace ID, because it's the same trace, but have different parents. This information is propagated through that context propagation mechanism. I'll show you examples again. With a temporal relationship, this shows the in a time graph where left to right, we see how a parent span spawns up the children and then how it all relates. So from a request point of view, the request starts here and ends here. So that's a single trace in that picture. This is all good. So what does this mean in terms of context propagation? So because I said all of these children have the same trace ID and the span ID. Let's see how that happens. So going back to my example, where app is creating a HTTP client and sending a request through. Let's say this is an Node.js application. It's making, so that particular activity is represented by span A. We've got a trace ID, obviously, because this is the root. We don't have a parent span. We make the request or the wire. It goes into the, let's say, ASP.NET Core application. It now creates a child span to represent this activity of this request being processed. It needs to have the same trace ID, and the parent span in this case is this, because the name of the parent was A. And the way it happened is by propagating this information across. Now, this ASP.NET Core application might have some services like dependence injected into, let's say, this controller. These 2 services might be processing or publishing a message and saving something to the database. One thing I want you to remember is these follow the same pattern. It's the same trace ID, and the parent is B because this is B. There's 2 things happening here. One is they all propagate the context. In this case, what type of information do we need in the context to maintain these relationships? We need the trace ID. We need the span ID. In this case, the span ID is the parent span ID in relation to where you are. In relation to B, the parent is A. In relation to C and D, the parent is B. Then you have some trace flags and trace states. So these things carry information about some additional information about the trace, which I won't go into right now. The additional aspect is I spoke about how this is one ASP.NET Core application. When you're doing if it's in the same process, you can use language semantics. In the case of ASP.NET Core, we've got the activity API, and we've got things like async local. If we wanted to implement this ourselves, right? We know how to have implicit context in .NET. It's not that hard. But the tricky thing that OpenTelemetry solves for us is what happens when things go over the wire. It has conventions for these as well, but the important factor is here. It does two things. One is injecting the context to the outgoing requests. So from Node.js, if this Node.js HTTP client in this case is instrumented, it will add this trace context into the HTTP headers. And from ASP.NET Core side, it's already instrumented. Therefore, it will hydrate its own internal activity, the parent activity internally, with the trace information coming from the HTTP request. And it has a thing called the W3C trace context, which is what is useful, because this now suddenly means ASP.NET doesn't care about what type of application is making the request. As long as the context information is in that format, we can consume it. And internally, it uses language semantics, but still adheres to things like how a trace ID should be displayed. Now, for keen observers, you know how I said there's three types of signals. There's tracing, baggage, and metrics. The baggage is another type of signal, completely different from tracing, but it uses exactly the same mechanism. In the case of baggage, it's key value pairs that piggyback off in that same HTTP request in the headers. I thought it would be nice to know, because in the demo I used baggages as well. Right, so this is the time to go into a demo. For those who are interested, I'll share this link in the chat. I've got this QR code if you want to quickly scan and join in as well. But 3, 2, 1, and I'll go to the demo. I hope people can see my screen and the text is readable. The first example I want to take on is a simple HTTP client making a request to ASP.NET Core backend. So this is the client application here. The ASP.NET Core application is shown here. I'll walk you through the code. As we go through, we'll inspect certain things. So the first thing I'm going to do is tell the application to use the W3C format. The reason for this is I spoke about how Activity API predates OpenTelemetry. So Activity API actually had a different sort of formatting that the .NET team came up with. In that sense, for backward compatibility, they can still support it. But in this case, we are explicitly saying we want the new one. We want the W3C context and the ID format. And then we are building the OpenTelemetry client. We are giving a name to this particular process here. Then we are opting in to an activity source. This goes into details about how the Activity API works, but basically in .NET, everything's opt-in, or as I would like to call it, tell me what you want, what you really, really want. When you opt in, if you don't opt in, it's basically as if a tree falling in a forest where no one's there. It's almost as if nothing happened. So opt in for those particular activities, and that's how OpenTelemetry can observe and forward those to the particular backend. And we are also doing another interesting thing here, which is opting into the HTTP client instrumentation. I did this using this NuGet library, and you'll see this stream all the way. And I'm saying I'm using Zipkin personally for this particular demo. So I imported this library at Zipkin exporter. I said, okay, I want to see it in my console too. Added this library at console exporter, as simple as that. And then when I'm calling the API, everything happens here. If I go to that particular method, I'm creating the activity source here, then spawning the activity out of that. That's the name of the activity. That can be anything you want. And because this is a client, I'm creating a client, that activity type is client. I'm creating some baggage, example baggage here. As you would have noticed, there's a separation between activity and baggage. Activity represents a span, like we discussed, but baggage is another type of signal. That's why there's this separation. There's two different APIs, one for spans and one for baggage. For anyone who's used activity API before, you'll notice that even activity has this thing called baggage. But if you're using OpenTelemetry, don't use this, because this is the old way of using baggage, and the OpenTelemetry clients don't support this. And I learned this as I was doing this demo. So we set some baggage, and we add some tags to the activity. So we are adding some key value pairs to the span. We are logging some things. We are then creating a event in the span. And this is another type of thing we can do on the span. And finally, this is nothing fancy. We make a call to our backend, and then the backend processes that request. So on the ASP.NET Core side, we do some things like, I'll go to the startup. We do the same things we did with the OpenTelemetry builder before. This time we are opting in for ASP.NET Core telemetry. I'm using SQL in this example, so SQL telemetry, adding the exporters. We've seen this before, nothing there. There's nothing special about the services or anything. This is simply what it takes to instrument ASP.NET Core. And in the values controller, which is the handler, I'm setting the current activity. And if all goes well, ASP.NET Core should be able to extract the context from the HTTP request coming in and set the current activity. And let's see this happen. Bear with me. I think I need to don't need this and this. Let's start this and see this working. So this is the HTTP client. I'm going to press a message to send the message, key to send the message. Got a breakpoint here. Let's a couple of things I want to focus on. I don't know how to make the text bigger, but basically, if I look at the context, look at the span ID here, right? It ends with FA8. So this is the root span of the thing we're creating to send the HTTP request out. And the trace ID ends with 78. So A8 for the span ID, trace ID ends with 78. Let's continue. I'll show you why this is important. So it's hit the values controller. I'll look at the activity here and see. So let's come here, values controller, activity, where was it? I'll actually let that, do I have activity? Yeah, here we go. So if I look at this, if everything went correctly, we should have the same trace ID. So the trace ID ends with 78. The reason why the span ID is different is because this has a interim parent that's in between. We'll go back to that now. So this is the actual child activity. If I go to the context there, we've got the same trace ID, but if you look at, there's something interesting here. Look at this parent span ID. It's picked up the parent span from the previous whatever activity that we created. So it's linked it up. It's linked up to the context nicely. And if I let this go, it completes and it prints the details out. But the thing to focus on is if I go to Zipkin, run the query, this is the trace for that particular request. Let's go in. So we had a HTTP client making the request. That's the thing. I'm gonna close this now. That's the thing we created here. Where's the outgoing request? And the instrumented HTTP library created this HTTP client trace, span, which has information. This has all the tags that I added in, and any additional information like this one. This is an event that I created, if you remember, and it's stitched together. In this case, this my backend service is coming from, where is it? In the values controller. It's this task, this call backend API. It's this task that's represented here. And before that, this local host, this is coming from the SQL client because it's instrumented again. It's putting the name of the server by convention. That's what SQL instrument, the client instrumentation does. But if you want to rename it, let's say you want to rename, like I did here, whatever you want to name your backend dependency, you can use that by adding a tag to your span, and that tag is determined by convention. Remember how I said there's a set of conventions for this OpenTelemetry that's done here. So that's how you can stitch everything together. I'll quickly show you a demo for situations where you don't have instrumented libraries and you have to instrument things yourself. I know I'm lack for time, so I'll quickly go through this. So for situations where you don't have instrumentation, I'm going to take an example of sending a message to RabbitMQ and retrieving that message. And if I let that run, it will come here. And this is the message publisher. And because there's no existing mechanism to set the context for that message like we had for HTTP client, I need to hydrate my model that's going over the wire with the propagation context. And I've used some helper methods here, which are all documented here if you want to look at the code base later on. But what it basically does is it puts this trace context, where's the trace? This propagation context into the model going out. And we then serialize it, send it over the wire. On the other side, when we receive it, let's let that go through. When we receive it, it's now our responsibility to extract the propagation context from the model. And the model itself has this is the trace context we put in before. We need to extract it ourselves because this is not instrumented by default, or we don't have a library. Luckily for you, 90% of all the libraries you use will be instrumented. I'm just showing you how to do this yourself if you ever need to. Again, if I let this run through, I've got some services here with things to make a SQL call and 2 calls to Google and Bing. So these are just some examples of some other activities you might be doing as a part of this, like some orchestrator. Let this run, and let's go back to Zipkin and look at that request. So that's the message consumer thing. As you can see, It nicely stitches everything together. Message published, consumed as a part of the consumer 4 activities. We hit these 2 things, our own backend service, and save something to the database. And it's got rich contextual information here as well. So this is the kind of thing you can do with OpenTelemetry. And how good is this compared to looking at logs? You can easily look at everything. And I'll also show you something. Look at this. It can even create a dependency graph for your applications and your dependencies. And you can see how different messages are traversing across the different dependencies. This is really cool from observability aspect. So I'll come back to the slides and finish this off. Come back. So we touched on the activity API, how in .NET it's represented by a span. And we also looked at baggage. We looked at the concept of context propagation, how we can do it ourselves versus using an already instrumented library, which will do it on our behalf without having to even worry about how that's injected and extracted. And finally, how I showed you how to directly export it to Zipkin or whatever observability tool of your choice. When I was doing it, there was, as soon as I typed OpenTelemetry.instrumentation, there were like 500 results that came through for different types of libraries. So go give it a go. You'll see that anything you use is already supported. And in terms of exporters, all the major ones are supported already. There are many more that are supported by the community as well. So don't feel like your hands are tied if you want to use OpenTelemetry with an existing backend. My message is start using this now. It's beta, but it's going to be general availability soon. You have options for greenfield as well as brownfield projects, good demos, get involved in the community. While I was doing this demo, I found there was some documentation that weren't up to scratch, created a PR. Please do the same. It's a great way to be part of the community.